Why is an element's mass number so important? Imagine trying to identify a person just by their height and weight. That's similar to how scientists distinguish different atoms. The mass number is like a unique fingerprint for each atom. It tells us the total count of protons and neutrons in an atom's nucleus. This number is essential because it helps us tell apart different forms of the same element, called isotopes. For example, carbon has several isotopes. Carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons and 8 neutrons. Even though they are both carbon, their mass numbers are different, which makes them distinct. Knowing the mass number helps scientists identify which isotope they are working with. This is important in many fields like medicine, archaeology, and environmental science. For instance, radioactive isotopes like carbon-14 are used to date ancient artifacts or fossils. The mass number also influences how stable an atom is. Some isotopes are stable, meaning they don't change over time, while others are radioactive and decay, releasing energy. Understanding this helps scientists predict how long an isotope will last and how it might be used. The mass number also makes it easy to find the number of neutrons in an atom. Since the atomic number tells us how many protons are in the nucleus, subtracting that from the mass number gives us the neutrons. This simple calculation is a key step in nuclear chemistry and physics. It helps us understand why some isotopes are stable and others aren't. In addition, the mass number affects the physical properties of an element. It influences the atom's mass, which impacts density and atomic weight. While the mass number is a whole number, the average atomic mass of an element, considering all its isotopes, is usually a decimal. For example, the atomic weight of chlorine is about 35.45 because it is a mix of chlorine-35 and chlorine-37 isotopes. In everyday life, the mass number explains differences among isotopes that can be used in real-world applications. For example, hydrogen has 3 isotopes: protium, deuterium, and tritium. Each has a different mass number, which affects their behavior in nuclear reactors, medical imaging, and water tracing experiments. So, the mass number isn't just a number. It's a vital piece of information that reveals what makes each atom unique. It helps us understand the makeup of atoms, how stable they are, and how they behave in nature and technology. This simple but powerful number connects the tiny world of atoms to the larger universe around us.